Okay, so the exam will be open book, or the test will be open book. Webcam has to be turned on. Okay, however, no recording. I will not record. Okay, so myself and a TA will be on the other side of the screen looking at your faces. No recording. Okay, we're not going to record at all. We're not going to monitor your computer activity. We're not going to monitor whether you use your whatever. Okay, so webcam has to be turned on, and usage of software okay, usage of any software is not allowed for all assessments. Okay, so the only software you can use are Microsoft Excel, Words, and what I'm doing now on OneNote. Okay, all other software are not allowed at all. Okay, we have students or in the manufacturing program. I'm the program chair for manufacturing. We have students using software in the final answer. Okay, unfortunately for them, okay, this was declared they have 0 for their final exam. Okay, so it's not worth the risk. Okay, anyone, any other questions, please? Anyone? Before I start lecturing, anyone, please?
Sir, the textbook, you had mentioned that it wasn't, it's open book. Are we allowed to use the PDF version of the textbook?
Yeah, you're allowed to use the PDF version. I'm fine with it. Okay. As I said, I've uploaded the PDF version. Now the textbook I have to bring it down within 24 hours. Okay, because what I'm doing is quite illegal, right? Okay. Anyone? Any other questions, please? Okay. If no, here we go. Okay. Now before I go on, I have also posted the homework. Okay, so these are the over here on the lecture. Okay, you go to week 1. Okay, you'll see Excel loading examples. So these are the examples I will be doing, and I've already uploaded the homework for Excel loading. Okay, so everything will be go on weekly. So the lecture notes will go on week 1, and also the posted videos. Okay, right. If no one have any question, I will start lecturing. Okay, so today's topic will be on stress and strain. Under Excel loading. Yeah, under Excel loading. So on the textbook, if you have to find, it will be on chapter 2 of your textbook. Yeah, it will be chapter 2 of your textbook. Okay, so what do we mean by Excel loading? Okay, so if we have a beam that is fixed to the wall, okay, to the wall or to the ceiling, and then this is our beam. Okay, this is our beam, and the beam has a specific A, which is our cross-sectional area. And then on the beam, I'm going to draw the axis. Okay, I'm going to draw the neutral axis. Sorry, I won't call this the neutral axis. I'll call this the centroid. Okay, and then I'm going to draw my transformation. So this is X, this is Y, and using right hand rule, okay, this is rotation about Z. Right hand rule means you use your right hand and you see how your hand is rotating, and if your thumb is pointing towards you, right, for this case, the thumb is pointing towards you, you can see how your hand is closing. So X, so how your hand close, X touch Y. Okay, so from here we have a load. Okay, we have a load coming down this way. So this load will be known as Py because it's acting in the Y direction. So load, as you can see, is applied parallel or along the centroid. Okay, is applied along the centroid. And you guys have done axial loading before. Okay, and this is done in static and dynamics. Okay, so in static and dynamics, what you guys have learned, okay, I'm going to sideward a bit just to hope that you will recall, is you have what we known as thrust analysis, okay, which you all learn in NSTAC 3SD3. Right, so I'll help you recall that some of you can't remember. Okay, so doing thrust analysis, okay, doing thrust analysis, all members are under axial loading only. Okay, you only assume that the structure can take axial loading only. Okay, so i.e. we ignore, okay, we ignore stresses induced by bending and shear forces. Okay, we ignore them. Okay, there's nothing wrong with it. It's just a way of simplify the analysis. Okay, nothing wrong with it. Okay, it's been used commonly. So what do I mean by members? Okay, so let's look at a simple beam. Okay, so we have a beam in this direction, and then we have another beam on the other direction at a certain angle. Right, we have beam in certain angle, and then the beam is held by two pins, and another here is also been pinned. Okay, so this is, I would call this A, point A. Over here it's been pinned also, point B, and then point C, right? So when we then let's say for this case, very quick example, we have a load applied in this direction, and this load is coming down as Py. Okay, so we want to find. Okay, so for this very short example to make you recall what is thrust analysis, we want to find the stresses in members AB and BC. Okay, so you could recall this, right? I know probably most of you have done this like 3 months ago, and you've written everything for your prof. Okay, that's why I'm doing the a short revision on this. So when you write this out, we can apply two methods. Okay, so the most common method is methods of joints. Okay, you apply the methods of joint. So you're going to focus, okay, analysis at point B. Okay, you're going to do analysis at point B. So we're going to draw the point. Okay, so this is our point B. Okay, so point B has two members, attaching two members. Okay, attaching two members. So one member is in this direction, and the other member is in the other direction. Okay, so the first line I've drawn, this is for member BC, and the other one is for member AB. Okay, so based on axial loading condition, okay, the structure can only take forces acting along the green line. Okay, it cannot do any otherwise. So for BC, it can only take horizontal forces. On AB, it can only take forces based on that orientation that you've seen. Okay, so now when we have a load Py over here, right? When we have a load Py over here, if there is no member AB, right? Py, the point B will go down. Yes or no? Okay. BC cannot take any vertical load. I'll write down here. BC cannot carry any vertical load. Right? And why is that? This is because we are doing what? Thrust analysis. Okay? We are doing thrust analysis. Okay? So the only member that can take Py load is ABY. So I'm going to draw ABY. Okay, why is it? I call it Y because I'm following the transformation. This is X and this is Y, and this will be rotation in our Z direction. Okay, so when that's the case, force AB will be going in this direction. So I'm going to sketch out force AB. Okay, so this is our force AB. Okay. Unfortunately for the force AB, right? So let's do some very simple calculation first. Okay. So we do positive that is going up. So we carry out static analysis. Okay, static analysis.